Hi, I'm Vint Cerf. I'm today Google's chief internet evangelist, but many, many years ago, Bob Kahn and I were the designers of the internet. And we're celebrating today the 40th anniversary of the publication of that specification in an IEEE Transactions on Communications. Our work was done by hand on a pad of paper. We didn't use terminals, we didn't use typewriters. We were at what was then the Hyatt Cabana Hotel in downtown Palo Alto, where we will hang a plaque commemorating all that work in late 1973. The paper was published in May of 1974. It was the beginning of the design and implementation of what we all today call the Internet. At the time, we were working on this as a military project. The military had built and had been operating a packet switch network called ARPANET, which stood for Advanced Research Projects Agency Network. It was designed to connect about a dozen universities together that were sharing computing resources and software in their further research on computer science and artificial intelligence. ARPA wasn't able to buy a brand new computer for every school every year, and he said, you're going to have to share, we're going to build a network, and you can, use each other's software and hardware. So we had several years, about 4 years of experience with the ARPANET project, during which time electronic mail had been invented. Many different computers of different kinds of operating systems had been interconnected using a protocol called NCP for Network Control Program. But it relied on the underlying uniform and homogeneous network, the ARPANET subnet. When Bob Kahn, who had done a lot of work on the ARPANET project, started thinking more about what it meant to use computers in command and control, he recognized immediately that he would have to use them in the air, in ground mobile vehicles, and on ships at sea. This translated into needing packet switching by radio in a mobile operation and by satellite for long-distance communication, ship to ship and ship to shore. So although he and I had worked together with many others on the ARPANET project, he was at Bolt, Baranek, and Newman, I was at UCLA, he came up to Stanford University in the spring of 1973, where I had moved up from UCLA after finishing my PhD. He had gone from Bolt, Baranek, and Newman to ARPA by that time. And so he sat down and said, listen, we got a problem. We've got these different kinds of networks. There are different packet sizes, different speeds, different rates, different error rates, and everything else. How are we going to hook them together and make them all look uniform? That was the Internet problem. So the spec was published in '74, and that year I began at Stanford University with many of my students a seminar on the design of internetworking systems. And by the end of December 1974, two of my students and I had written the detailed specifications for TCP. We then began implementation, and Bob was very clear from his position at ARPA that he didn't want this to be entirely domestic. So he brought in researchers at University College London and Bolt, Baranek, and Newman in Cambridge, Massachusetts, and eventually also people from Norway and from Germany and Italy to participate in the design, implementation, and testing of these new protocols. So by 1975, we're deep into implementation of the protocols, and of course we immediately discover they don't work right. So there's a series of 4 iterations of the protocols leading up to around 1978, when we had split what had once been a uniform end-to-end protocol for delivering sequences of really bytes from one computer to another through multiple networks. We split off a portion of the protocol we call now Internet Protocol. For all practical purposes, you can think of this as postcards. The postcard has a from address, a to address, and some amount of text. And everything you know about postcards applies to the Internet, right? When you put a postcard in the post box, there's no guarantee it comes out on the other end. This is true of the Internet packets. If you put 2 postcards in the post box, they don't come out in the same order you put them in. This is also true of Internet packets. One thing that the Internet can do that the post office doesn't is if you put 1 packet in, sometimes you get 2 out because they've been routed in multiple directions. They both may show up. So now you have to deal with duplicate detection at the other end. Things get out of order. You have to sequence number everything. So the IP protocol is like the postcards, and the TCP protocol is like putting everything back together in the right order. So by 1978, we have a solid protocol. We think it'll work, but now we have to implement it on about 30 different operating systems, which represents the variety we had on the ARPANET at the time. So it takes us another 5 years until late 1980, well, actually, late 1981, at which point we realized that we were going to have to now literally get this thing running on all the computers that are on the ARPANET, the Packet Radio Net, the Packet Satellite Net, and our friends in the UK. So John Postel, whose name came up frequently today in our discussions, was sort of the manager of the RFC editor. He managed the allocation of internet address space. He managed the domain name system, which actually didn't get invented until 1985. So in 1982, we announced to everybody on the ARPANET, we are going to switch over to the internet protocols on January 1, 1983. If you're not ready and operating by then, you know, your contracts are gone. That provoked a certain amount of incentive to get this done. So during the course of 1982, Dan Lynch was monitoring the implementation of TCP on the various computers of the ARPANET. And it was going along pretty well, and around June or so, it flattened out. So now by this time, I'm at ARPA as well. And I said, I called the guys running the ARPANET, and I said, shut off the ability to run anything but TCP. Shut off the NCP protocols for a day. And of course, you know, so they could do that, right? And of course, everybody was screaming and yelling, what have you done? My email doesn't work. I can't get to my other computers. You know, the file transfers are over. And I said, I just wanted you to know I can do that. So then, the curve starts showing up again. Dan says, they're implementing. Then it flattens out in October. And so I called them up and I said, shut it off for 2 days. NCP is gone. Only TCP will work on the ARPANET. That got a lot of grumbling as well, but at least, we got done. So only 2 sites, as far as I know, were not quite ready to go on January 1, 1983. Now, let's fast forward a bit. The Internet is now in operation. We discover it's growing very quickly, and we need to deal with the fact that we've been manually handling the names of computers mapping into internet addresses from symbolic to numerical addresses. And we have to invent something called the domain name system, which I'm sure most people are familiar with now. Paul Makapetris and John Postel at USC Information Sciences Institute developed this idea. Eventually, that becomes the heart of the way we navigate around in the Internet. Then in late 80s, in 1989, Tim Berners-Lee invents his idea of the World Wide Web, and he uses these domain names in the hypertext markup language in order to describe places in the Internet where you could go, websites. Ironically, about that same year, we see the first 3 commercial Internet services arising in the United States. So the first commercial operation starts then, 25 years ago. And at this point, if you were measuring the growth of the Internet, you would see it growing at 100% per year, number of machines, number of networks, number of users. So we now have an explosive thing on our hands. The World Wide Web, which went unnoticed until about 1993, when Mark Andreessen and Eric Bina invent their graphical version called Mosaic, the graphical browser. Jim Clark recognizes this, drags drags Mark Andreessen to Silicon Valley, starts Netscape Communications. Within a couple of years, they launch their IPO. It's the most explosive result on the stock exchange ever seen. The dot boom is on. And it goes until April of 2000. Then the dot bust happens because people have been throwing money at companies that don't have good business models. But underlying all of that, the Internet is still growing at 100% a year, right through that dot bust. So we're into the 2000s, and at this point, we're starting to see new applications showing up, including encoding voice on the Internet protocol, and encoding video on the Internet protocol. This was the second iteration of this because we were experimenting with this during the research period in the 1970s with packetized voice and packetized video, because we knew the command and control would need voice, video, and data. But by the 2000s or so, we're starting to see serious implementation in the commercial sector. Along comes the smartphone around 2007 or so, and this, of course, triggers a whole other explosion because now the Internet is available in mobile operation. So this brings us up to the present, 2014, where we're seeing an uncounted number of new applications coming, many of them on mobiles or on pads, as well as laptops and desktops. We're seeing countries that are authoritarian in nature wanting to shut the internet down because they don't want people talking to each other or knowing what's going on. So there's this giant discussion about internet governance, which is the current topic A, I would say. And so today, the freedom and openness of the internet is under threat. And many of us who've been part of this story for so long are fighting very hard to make sure that the internet stays the open, free, and source of permissionless innovation that it has been for many, many years. At the same time, we're all very conscious that because we depend heavily on this network, we are dependent upon its safety and security. And there's work to be done to improve that as well. So the internet is not a static thing. It is still evolving. The applications continue to evolve. New protocols come along. Security has to be added to the system. So we still have a lot of work to do. And it's not over yet, not only terrestrially, but the next step is off-planet. And for the last 15 years, NASA, the Jet Propulsion Laboratory, have developed, implemented, and deployed an interplanetary network linking Earth, Mars, the International Space Station, and a satellite that's in orbit around the Sun. So, the rest of this century is going to be filled with internet stories. I wish I could be around to see all of them, but I hope I'll see a few of them between now and whenever I go off to my reward.